Hello everyone, I am Dr. G. Swapna, Assistant Professor in the Department of Mathematics, VNR VJEC. Today we are going to discuss the solutions of non-linear partial differential equations. First we discuss about that what is a non-linear. Linear means that first degree. Non-linear means that other than the first degree. An equation, a partial differential equation in which P and Q occur other than in the first degree, then an equation is called nonlinear partial differential equations. For solving these nonlinear differential equations, we have mainly Charpit's method is there. But it is very lengthy procedure. Other than that, we have some shortcut methods are there. Those shortcut methods are used some particular forms of the differential equations. First, we are going to discuss about those short forms and then we discuss about the Charpit's method. Now, method 1, this is when the given equation is in the form of f of p comma q is equals to 0. That means that an equation having only p and q, it doesn't having any other variables. If it is like that, then consider the solution is z is equals to ax plus by plus c. From this equation, find the p and q values. That p is nothing but dou z by dou x, which is from this equation derivative of z with respect to x is a, and q is nothing but dou z by dou y. Derivative of the assumption equation with respect to y is nothing but b. Substitute these a and b values, that pq values, in the equation 1. Here p is equals to a and q is equals to b. Substitute, then you will get it as in the equation in terms of AB. Now, substitute this p is equals to a and q is equals to b in the given partial differential equations. So, then you will get the relation between a and b. So, if you substitute, then you will get it as function of a comma b is equals to 0. Then find it out the b value in terms of a and substitute that b value in the solution which we consider. That is z is equals to ax plus by plus c. Then you will get the required solution as ax plus function of a plus c. This is our required solution. Because here the differential equation is of first order. That's degree is higher but order is 1. So first order differential equation is obtained from the relation which is having a two arbitrary constants. Here a and c are the two arbitrary constants. Now let us explain with the example. Solve root p plus root q is equals to 1. Here if we observe, this is partial differential equation which is of first degree. What is the order of this differential equation? P is nothing but dou z by dou x and root p is nothing but, that is nothing but power 1 by 2. That means degree is 1 by 2. That's other than 1. So it comes under non-linear. And it is also having, equation is having only p and q. Then you can apply the same procedure which we discussed just now. So, we assume that, let us consider z is equals to ax plus by plus c is the solution. This is the solution of given equation. Okay. So, now from this find out the p and q values. P is nothing but dou z by dou x. Differentiate the z value with respect to x, that is nothing but a, and y is a constant and c is a constant. So total terms are constant, you will get it as a 0. Similarly, find the value of q, that is dou z by dou y, which is differentiate the z with respect to y now by keeping x as a constant. So 0 plus b constant, derivative of y is 1 plus again 0. So it would be b. So replace p is equals to a and q is equals to b in the given equation. That is root p plus root q is equals to 1. Just replace p by a and q by b. Then find the value of b or express b in terms of a. So root b is equals to 1 minus root a, and b is equal squaring on both sides. B is equals to 1 minus root a whole square. Now substitute this b value in the solution which we consider. So therefore, required solution is z is equals to ax plus b is replaced with 1 minus root a whole square into y plus c. So which is our required solution. This method is applicable only when the given partial differential equation which is non-linear in the form of f of p comma q is equals to 0. It means that the equation is having only p and q. Next, now we discuss another method, that second method. If the non-linear PDE is of the form f of z comma p comma q is equals to 0, it means that the equation does not contain x and y. It is having only three of variables z, p, q, where p and q are the first order partial derivatives. In such a case, here also we assume the solution u as x plus ay and substitute p is equals to dz by dy and q is equals to a into dz by dy du in the given equation. How to find out this? How will you get it these values? Here u is equals to x plus ay. We need to find the p value. P is nothing but dou z by dou x. So z is expressed in terms of u, where z is a function of u, where u is a function of x and y. Applying the total derivative concept, dou z by dou x is differentiate that z dz with respect to u first, because it's having only one independent variable. So dz by du into dou u by dou x, because u is a multivariable function. So which is dz by du into dou u by dou x. This is u, so dou u by dou x is 1. So we replace p as dz by du. Similarly for q. Q is nothing but dou z by dou y. So which is again applying the total derivative concept here. Dz by z is a function of u. So that's z is depending only on one variable. That's an ordinary derivative. That's dz by du into derivative of u. U is a multivariable. Dou u by dou y, which is dz by du into dou u by dou y. Derivative of u with respect to y is a. So we are replacing q as a into dz by du. If we are replacing this p and q as a dz by du and a into dz by du in the given equation, then the equation converts into a ordinary derivative. Now we can solve that ordinary differential equation in z and u by using a variable separable method. And finally, you can replace u is equals to x plus ay in the solution which we obtain. Now we will look into example. Here observe, in this example, it is having only z, p, q. It does not having x and y. It doesn't having x and y. So we can apply this method. So in this method, let us consider u is equals to x plus ay as we discussed just now, just replace P as dz by du and Q is replaced with A into dz by du. Now substitute that P and Q in the given equation. Then we will get z square is equals to 1 plus P is nothing but dz by du whole square plus Q square A into dz by du whole square. Just simplify this. So z square minus 1 is equals to, take dz by du whole square as a common, dz by du whole square into 1 plus a square. So now that's dz by du is equals to square root of z square minus 1 by 1 plus a square. Just simplify this. Just here observe, this is an ordinary differential equation in z and u. Just applying the variable separable method, thus you can write all z terms in one side and u terms in the other side. 1 by square root of z square minus 1 dz is equals to 1 by square root of 1 plus a square dz. Just integrating on both sides. Now integral of 1 by square root of z square minus 1 dz is nothing but cos h inverse of z is equals to, here 1 by square root of 1 plus a square is a constant, integral of 1 dz, sorry, here du. So here integral of 1 du is u plus integrating constant b. So here then that is nothing but cos h inverse z is equals to u by square root of 1 plus a square plus b. This is our required solution. Here also observe, this is differential equation of first order and higher degree. That's a non-linear partial differential equation. First order means the solution is having two arbitrary constants. Here a and b are the two arbitrary constants. Next, we will discuss another method. Now, if f of p comma x is equals to f of q comma y, the equations not containing z and terms containing x and p can be separated from those q and y. So definitely the equation whatever it is given in the problem, that we are able to rewrite in the form of f of px is equals to f of qy. Then only we are able to solve by using this procedure. Assuming that f of x comma p is equals to f of y comma q is equals to a, individually equating that each function with the arbitrary constant a and solve these equations. This now you are getting f of x comma p. P is nothing but ordinary derivative, that's a partial derivative dou z by dou x. Just simplifying and solve the p value. Find out the p value in terms of x and equating f of y comma q is equals to a. Each function is equated to a and then find the value of q. Substitute these p and q in dz is equals to p dx plus q dy. Why we are substituting in this? Because z is a function of x and y. So z is a function of x comma y is the solution of any partial differential equation, and here by total derivative dz is equals to dou f by dou x into dx plus dou f by dou y into dy, which is nothing but p dx plus q dy. That's why we are substituting that p and q values in dz is equals to p dx plus q dy, where p is a function of x and q is a function of y. Then you can easy to find out the z value just by integrating this equation. That is the procedure to find out when the given equation is particularly in this form. We'll look into one example. Now here observe, solve root p plus root q is equals to x plus y. Now we are rewriting. First we need to observe whether this equation is able to rewrite in the form of f of p comma x is equals to f of q comma y. Here observe, this we can easily rewrite. Just rewrite it. Root p minus x is equals to y minus root q. Just equate this is equals to some a, some constant, arbitrary constant. Now equate each term, that's root p minus x is equals to a and y minus root q is equals to a. From these two equations, find the values of p and q. Root p is equals to x plus a, p is equals to x plus a whole square. Similarly, find y is equal, root q is equals to y minus a, q is equals to y minus a whole square. Now substitute this p and q in dz is equals to p dx plus q dy. Now dz is equals to p is nothing but x plus a whole square plus y minus a whole square into dy. There it is dx. Now from this is the value of dz, just find the value of z from this by integrating on both sides. Just integrating on both sides. Now integral of dz is z is equals to integral of x plus a whole square, x plus a whole cube by 3 plus integral of y minus a whole square, that is y minus a whole cube by 3 plus integrating constant b. This is our required solution for this equation. So here clearly observe that this method is applicable only when we are able to rewrite as a function of x comma p is equals to function of y comma q is equals to a. If we are able to rewrite like this, then only we are applying this procedure. Next, we are going to the next method, that's a fourth one. Now, if z is equals to px plus qy is plus f of p comma q, equations containing p and q only. Here, this equation is called Claret's equation. Particularly in this form, there is no other forms is suitable. It's not suitable for this method. Particularly, the equation is of the form z is equals to px plus qy plus function of p comma q. Sorry, here some mistake. Here the equation is of the form z is equals to px plus qy plus f of p comma q. This particular form is called it as a Claret's equation. So this is a very short method. Then we can directly replace that p is equals to a and q is equals to b. Then the solution of Claret's equation is z is equals to ax plus by plus f of a comma b, just by replacing p by a and q by b. So here observe, solve z is equals to px plus qy plus square root of 1 plus p square plus q square. Here observe, is it in the form of Claret's or not? Only the thing is it in the form of Claret's or not? This is in the form of Claret's. So simply evaluate write the solution. That solution of the Claret's equation is z is equals to ax plus by plus square root of 1 plus a square plus b square. That's it. Okay. In the next video, we will continue with the Charpit's method. That is a general method for solving the nonlinear differential equation. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.